Hi everyone, this is me Guneet, and we are Group 10 presenting on the topic Making Middle Boxes Someone Else's Problem, that is, using network processing as a cloud service, along with my teammates Lekha and Mohammed Hanan. Here, to understand what our topic is, we first need to have basic understanding of what are typical enterprise networks. So, in the case of typical enterprise network, we have some nodes. The nodes are then connected to switches, which are connected to routers and then connected to the outside world, that is the internet. Now, we have middle boxes in them. That is, the purpose of the middle boxes is to have firewalls, intrusion detection systems, web proxies, load balancers, etc. The diagram here is really complex. Now, what we can do is, here, in this case, what our approach would be to minimize the amount of effort needed so that this complex diagram gets converted into something simpler, because simpler is easy. The more things simple are, the more better they have their efficiency and performance. So the researchers decided to conduct a survey for 57 enterprise network administrators over the range of sizes ranging from 1,000 hosts to 100,000 hosts. They asked them questions about deployment sizes, expenses, complexity, and failures. So, after performing the survey, the insights that they found were as follows. The kind of middle boxes that they deployed ranged from IP firewalls to intrusion detection systems. More the number of devices are, more expertise is needed. So, how this works is when they asked them a little bit more in detail, the administrators told them that the number of firewalls when optimized, number of proxies, etc. And the first thing they noticed is not the value of number of devices when they step back about this to the management. It means that the wide range of expertise we need to manage the firewalls and security devices of these performance oriented devices, it tells that we need to manage one and another. There were various instances in which every in which an organization had different teams for each department. Like there was a separate department handling the firewalls, there was a separate department handling the load balancers, and a separate department for intrusion detection systems. Now the question arises, how many middle boxes do they need to deploy? And how do they scale this? So to answer this question, we have this diagram where the box plot here represents different size or networks. The lavender shade here represents the small number of devices, smallest networks, and the red represents the largest networks of 100,000 or even more. So the green and blue here, the green and blue are somewhere in between. Now, as we can see, the y-axis here is in the log scale. So the key thing to note about this plot is it across both the box plot line up right the number of middle boxes. So we are deploying more and more middle boxes, thus the number of middle boxes is typically on par with the number of routers and switches. From this, we get the idea that our networks are getting bigger and bigger. Not only we're deploying more and more routers and switches, we are also now deploying more number of middle boxes. So, since the number of middle boxes are growing exponentially, what does it mean to manage middle boxes? That could somehow relate to upgrades and vendor interaction, monitoring and diagnostics, configuration, which includes appliance configuration, policy configuration, and training. This can somehow, we can relate to this somehow in terms of a democratic government. So, why do we need to manage a country? We need to manage a country to create new policies. That is to make sure that the economy is growing well, it's not declining or it's not stable. So the economy needs to grow up. That is somehow related to adding the number of features here. And there to add new hardware, that is to add new parties in the democratic system, let's say Aam Aadmi Party or BJP or some other party, that is there are the different type of hardware available which are implementing new policies or new features to the middle boxes. Now, how many network personnel do we need? For a simple number of middle boxes, we need around, for medium like 10 to 100, we need around 6 to 25 people. And the salaries of the network administrators are from 60 to 80,000 US dollars. So for one or two administrators, as you can see, if there are one or two administrators, then the number of middle boxes are not that much. But as per our discussion, we get to know that the number of middle boxes are growing a lot, and these are around 10,000 middle boxes which require 500 plus personnel. So if we continue this approach, we need to have a lot of people managing the middle boxes. Then our next question which arises is how sorry for that. How much do these middle boxes cost? Around 10,000 of these middle boxes can somehow range from 1 million to $50 million. That's a lot. I don't think over 5 years a company is willing to expend that much amount just for the middle boxes. So, considering our previous scenario where we discussed about the number of personnel required and they question the administrators, how do they spend their time? Most administrators spend 1 to 5 hours per week dealing with failures. 9% spent 6 to 10 hours per week. We had misconfiguration, overload, physical and electrical issues. So, the question here was to minimize all this complexity and to wrap up into a simpler model. To do this, what we have done here is to decrease the computation and to make management at ease. We decided to move all of this into a simpler compact version, that is the cloud. Moving this to the cloud, we eliminate high-end capital operating expenses and use a pay-per-use model. So the benefit of the pay-per-use model is we don't need to invest a lot in the hardware. Instead, what we do is we pay for what you're using. Like it's similar to building a house. You don't build a house, you just pay the rent of the room you live in. Then we have time consuming and error prone. The move to the cloud makes things simpler in configuration and deployment. You don't need to set up all the infrastructure, collect wood, collect bricks to make a house. Then the physical and overload failures are gone because all of these resources, instead of being a single point of failure, are divided over the cloud, that is, over various data centers.
Hello everyone. We have seen that a move to cloud will make our enterprises infrastructure easier in terms of middle boxes. To achieve this, so when we initially have seen that the middle boxes are maintained by an enterprise and the requests are carried between the client and servers by the enterprise itself. To make it simpler, now we are moving it to the cloud. To achieve this in an efficient way, we have certain design principles. So the first design principle is redirection. So when there is a request between a server and a client and a client and a server, and when middle boxes are involved, the particular request needs to move to the cloud to perform a middle box action like a firewall action or an intrusion detection action or whatever the middle box action that needs to be performed. For that to happen, we need to redirect the request from server to the middle box to the client or vice versa. For this to happen, we need redirection. So there are three different types of redirections. First one is bounce redirection. In this particular redirection, the epsilon gateway, that is the gateway that allows this particular infrastructure to happen in this particular research paper, uses is the only one cloud aware for this particular redirection to happen. So that is, the request is directly bounced to this client after performing the middle box action by the epsilon gateway. The next one is IP redirection. In IP redirection, the cloud provider will provide the IP prefix on behalf of the enterprise. So the enterprise need not get involved in the redirection. Coming to the DNS redirection, the cloud provider will have a DNS resolution middle box in it that will provide the DNS resolution on behalf of enterprise and will register the DNS names on the client's external service. So the second design principle is to minimize the latency. That is, when a request is being processed from server to the client, since there is a redirection involved, the RTT time could be more. To minimize this latency, we have different approaches. Instead of directly redirecting the request to the cloud POP with minimum RTT, we look at each request and based on the destination of the request, we will choose a particular POP. That is, for each enterprise E and based on the client C, we'll have a combination of E and C such that the cloud POP that we are choosing will have minimum latency between E and C. To achieve this, we have epsilon gateway. So an epsilon gateway is nothing but an appliance for outsourcing middle boxes, that in which a gateway is going to come between the middle boxes and the server enterprise. So this particular epsilon gateway will ensure that the tunneling of multiple cloud POPs and the inbound traffic to the appropriate cloud POPs are performed efficiently. So each particular enterprise can have its own epsilon gateway and can allow redirection like through multiple tunneling through multiple cloud POPs, and can also perform administrative tasks. Now let's see how inbound traffic is actually processed. So when there is a request from a particular client, the client sends the request and the epsilon gateway will directly redirect the request to the particular middle box that needs to be redirected to, and the action is performed and will be sent to the enterprise. Let's see if all the middle boxes that we generally use for internet can use epsilon gateway. So the first one is firewalls. We widely use firewalls. So epsilon gateway can be used for firewalls, and also for intrusion detection systems, for load balancers, for VPNs. But for proxy caches and WAN optimizers, it cannot be used. Since a proxy cache is a data heavy application, we need more bandwidth, and an epsilon gateway might not be able to process this request with the required minimum latency. And also in case of WAN optimizers, it might not be able to provide the required compression. This problem can be solved using epsilon plus gateway that will act like a CDN, a content delivery network, that can provide compression and can provide these particular applications also. So in case of APLOM gateway, uh, these processes will be also performed. Now my friend Hanan will provide you the evaluation of APLOM gateway.
Mm. Hello, I am Hanan Desai, and I am going to talk about some of the discussion in terms of the Aplum architecture and what future enhancement we can do to make it more global in terms of the architecture. So, some of the discussion that is currently going for the Aplum is that now the future is of the hybrid architecture. As now, if in the paper it was mentioned that they have done some basic survey with the network administrators across the companies, and they said that they have the task in the next few years to completely transfer their in-premise data centers to the cloud. And also now the government has government services are also moving from the in-premises to the cloud. So this Aplom complements the shift from local to outsourced cloud infrastructure. And also this Aplom simplifies the middle box deployment in hybrid model and consolidating the complexity. So basically, if so now the s- now the servers are all also going to the cloud. So basically, if our middle box are in also in the cloud, then it will going to be more like a suitable architecture for the middle box. And in the same way, if we have the middle box in the cloud, separate middle box in the cloud, so it will reduce the complexity of the cloud infrastructure as well. Okay. The second point about this discussion is about the cost dynamics of the Aplom. So although Aplum reduces the middle box infrastructure cost, but yeah, it is increasing the bandwidth cost. As the it's because whenever any traffic is going, so it will first go through the cloud network, and then it will go to the our backend server network traffic, right? So it will increase the bandwidth cost as well. And there are some techniques such as redundancy elimination compression reduces that will reduce this bandwidth cost. So yeah, we can implement it so to achieve the aplum and to have some reduced bandwidth cost. And also that we are talking about the making implement the middle box third party middle box in the cloud premises. So now the cloud providers are have the model of pay per use. So we only have to pay so whatever the volume that we are using, right? So if we have if we have some less amount of traffic, then we only have to pay for that much of traffic. And if the traffic is increasing, then our the cost is going to be increased. But most of the cloud providers services like Amazon is there, Arkama is there, so they have some plans that for the less traffic they have some particular amount, and with increasing amount of traffic plan they have some reduced plan for it. As a network, as a middle box service provider, we can have they can have advantage of wholesale bandwidth pricing, which is priced by transfer rate. And yeah, one of the most important things in the to implement the middle box and the aplom is the security. So as we know that cloud computing has also some security questions, but still uh, as we discussed, that most of the servers are currently moving from in-premises to the cloud. So there are some security concerns for the cloud, but still it hasn't stopped its widespread adoption. So what are the security concerns? As if we know that in the cloud computing, so the data is available to the cloud provider in the unencrypted format. So as the same way in the cloud middle box, it has access to the unencrypted traffic to the provider that is providing the middle box, right? So yeah, we can the so Aplom enhances that. Aplum encrypts the tunnel traffic to and from the enterprise to protect against the man in the middle attacks. But despite this encryption techniques and all this, there are some industries and there are some data which is considerable to that, which is not like for the data that cloud services are not in compliance, and they are not allowing the data to be uploaded on the cloud. If we talk about, if in the Germany, so in the German government doesn't have the rule to not upload the health related data on the cloud. So for that we only need the on-premise servers. So in that case, in that type of cases, this Aplom will not going to be feasible solution for that. Okay, so this is like a future improvement. So this is not included in the paper, but yeah. So the fault tolerance middle box. So this concept was introduced somewhere back in 2015 by some of the student in the university, and it was awarded as the best paper of that time. So as we know that middle boxes are the stateful systems, and any point of failure in the middle box can leads to a financial loss or missed and attacks to the data leak and attacks to our data server. So fault tolerance is very crucial for the middle boxes or for competitive and desirable services. And middle boxes vendors traditionally focused on fixed function hardware solutions. So yeah, so the Aplom middleware that we are talking about is totally it's based on some of the hardware solutions. But if we really want to implement some of so if we really want to implement the solution that is feasible and that is going to be widespread adoption, widespread acceptable, then we need some solution that is totally based on the software. So yeah, so at FTMD's fault tolerance middle box is kind of the idea in that direction, and it achieves so it is a software based middle box architecture, and it has some advantages like it achieves the median latency overhead of only 3 microsecond per packet and significantly lower than general cloud system approaches. And FTMB's optimized ability to commit data quickly in packet processor result in a minimal latency overhead. And this FTMB is already been recognized by some of the institute in the Europe, and AT&T has also adopted one of the part of its in its provider services. So yeah, so AT&T is also adopted the Aplomb as well, and with that they adopted the FTMB as well. So some middle box vendors are conducting trials with FTMB. So yeah, so there are many middle box providers available in the market, and they are conducting trial with the FTMB. So we didn't really looked much into this topic, but this looks like a promising one if we want to take middle boxes to the cloud. Okay, so finally we comes to the conclusion parts, that outsourcing to the cloud. So yeah, so outsource the middle box to the cloud relieves enterprise of major problems associated with the current enterprise middle box infrastructure and addresses issues such as cost management complexity, capacity rigidity, and failures. So we in the research paper provide one of the model to implement this is the Aplum system. So it is a practical system for middle box processing in the cloud, and it successfully outsources the majority of middle boxes from typical enterprise network without impacting performance. So yeah, so that's all about this paper. So this paper talks about making middle box as transferring middle box from in premises to the cloud, and also there are some techniques associated with it. Okay, how should we redirect the traffic? So for all that, the DNS based approach is the best one. And then we comes that some of the challenges in the outsourcing middle box to the cloud, like security concerns and costs, and how can we overcome that. And the last we talked about the FTMB, that is the approach, so that will make this research papers techniques more feasible to the general network scenario. So yeah, that's all. Thank you.